Aloha, this is Richard Halverson, ICS321, and today is September 23rd. And we are, let's see, let me share my screen. And we are around here. So looks like we're starting chapter 3 today. And I remember I was going to start chapter 3 before I got into this. So I might get into this assignment today. That might be a good idea. But let me just check for sure where we are. So I go to the playlist and I repeat this every time. But it's a good idea if you want to know, like, you're looking for something because you're trying to do something in the textbook or whatever. The playlist should say, you know, around where you are, but you can see where I am in the chapter right up at the top here. So right here, I'm in section 2.8. And, you know, I think, am I in section 2.8? I think I'm in section 2.8. Oh, here's section 2.9. That's right. Section 2.9 was this relational algebra section. And I think you only have to go through and do the participation exercises. But anyway, so it looks like we ended in 2.9. And so we can start chapter 3 today. So let's get started. All right, chapter 3. So we're going to start learning about SQL, and there's a bunch of labs. You know, that's right. I put all the labs in this chapter. So there's a bunch of labs in here. Okay, so maybe we'll just spend some time doing some of these labs because those are all points. All right. So so SQL is a high-level computer language for manipulating relational databases. And so we're going to learn the SQL language, and SQL is one of these languages where, you know, in the 80s, I think 70s and 80s, they created SQL. I can't remember when they started it, but that's the language of databases, and it's been SQL ever since. I mean, they've different companies that support SQL, like Oracle and so on. They will come out with SQL enhancements to the SQL language, but the SQL language has stayed the same ever since. You know, if you look in Microsoft Access, that program uses a version of SQL that was like the 1992 version or something like that. Still good. So what's great is when you learn SQL, you will have learned a language that you can continually get better at. You know, perfect your craft of writing SQL for as long as you're a database programmer. It's not like programming languages. Programming languages, of course, every 10 years there's a new programming language. That's the hottest thing, and you know, since computers were invented, and you know, you got to learn a bunch of new stuff. So anyway, which isn't so bad either. But anyway, so the other thing about SQL is that it's a language where when you write the SQL statement, you're describing what you want the result to be. You aren't describing how to get the result. Okay, programming languages, you write a program and it's a sequence of steps. It's computational thinking, a sequence of steps where if you carry out all those steps correctly, you'll arrive at the solution. Whereas with SQL, you just write this one statement and you leave it up to the SQL processor to figure out the best way to produce the result that you've defined that you want. So in this, SQL commands can create database. Yeah, use SQL commands to create the database, to manipulate the database, to set permissions and access rights and all that. It's all SQL. So let's see, SQL commands can create databases and tables. Yes. Database designer and database user both use SQL. Yes, that's true. And all database systems use identical SQL statements. Well, I don't know about the answer to that. The variations, I bet you the answer is false. All right, vary. All right, so this is the SQL syntax. We're going to talk about that. There's selecting, and there's inserting, and there's updating, and there's deleting. Those are the 4 kinds of commands of statements. And there's often you identify the table that you're doing it on, or it could be more than one table, a collection of tables, and there's usually some restriction thing. And this restriction thing is true for selecting some records out of a table. It's true for updating some records in a table, and it's true for deleting some records in a table. Selecting, the select clause, you're selecting rows, but maybe you don't want all the columns. Maybe you only want some of the columns or one of the columns, and so that's what this clause is for. So there's of course, as in any language, we have the concept of a literal, which is a value. There are keywords, which are reserved words, which mean something in the language. There's identifiers, which are like variables, variable names, table names, column names, and then you can have comments. So the insert statement adds a student to the student table. How many clauses are in the insert statement? I don't know, it's 2, I guess. I mean, it's silly questions. I'm going to say 2. Yeah. SQL statement below is used to select students with last name Smith. What's wrong with the statement? What's wrong with the statement is you have to put the Smith in quotes. Otherwise, in this case, you're talking about, maybe the value in column last name is the same as the value in column Smith. Okay, so this is an identifier, and really what you mean is a literal. So it's got to be in quotes. And by the way, it really should be in single quotes, even though this says it can be double quotes. It can't always be double quotes. In fact, when you get into some of these labs, I know this because I've used this textbook before, really you should use single quotes. Okay. Anyway, so even though it says double quotes here, the where clause should be removed. What's wrong with, oh no, never mind. Okay, what's wrong with this SQL statement? Select first name from student. Okay, this thing says the terminating semicolon is missing. I think that's probably what the answer is. But even though you don't have to have a terminating semicolon. I think it's this one. What's wrong with this statement? Well, this is a comment. This is how you start a comment. So the from is a comment. Yeah. So anyway, okay, so they call these sub-languages the data definition language, the data query language, the data manipulation language, all this. And basically it's just categorizing a bunch of all the different kinds of SQL statements into like what they do or what they're for. So you should, this defines this create statements. This is a select statements. This is update statements and delete statements and insert statements. And this is database control language statements. And this has to do with if you want to make more than one statement, like indivisible, you know, so once it starts, it ends kind of thing. So there's a language for that. We'll learn that. So, okay, so here you should match these up to make sure you understand what all these are. So anyway, you should drag and make sure you understand what those are. Okay, so these are the statements to create a database and to drop a database. It's this create statement. So this is going to create a database called pet store, create a database called bike store, drop the database called pet store. Anyway, so you can click through this, make sure you click this so you get all the points. Assume the database currently contains only one. Assume the system only contains one database called university. The statement this creates a database called auto. I guess it does. The statement this creates a second. No, I think you get an error. You can't have more than one database. So I think you get an error. Yeah. The statement drop deletes the, yeah, I guess it does do that. I don't use that. I don't drop databases. Yeah, this is true. Uh-oh. Oh, well, this has to exist before it can be deleted, and that's the point here. Because it only has, because we're still working with the same system. We're still working with the same system. So it should be this answer. Good, now I got the points. Okay, the show statement, the show statement is used because, so it lists out in tabular form. So basically this generates a table with these fixed column names and so on. So you can see what all the things are about a table, all the tables in a database, all the databases in the system, all the tables in the database and so on. And so you can actually, this is a table and so this, show columns, okay? So this generates a table. So this can be used anywhere there's a table. You can select field and type from this, probably put in parentheses and put an alias name so you can refer to it. But anyway, so that's what this does. Which statement shows all the databases in the system? Well, I guess it'd be this one. Which shows all the tables in, is it this one? No, it doesn't have a from clause. We have to be in, we have to have already selected pet store. And then we can do this one. All right, so make sure you get those. As soon as we get to some, we're going to get to some labs. Oh, good. There'll be some labs coming up here. All right, creating and dropping tables. We're still doing this. Oh. All right. Anyway, these are common data types. I wonder why this is in creating and dropping table. That's weird. To create a table. We have to know about this, to create a table, because creating a table is specifying a bunch of columns. That's all it is. It's specifying a bunch of columns. It's specifying the columns of the table. And so these are the column types. And these are strictly enforced, which is one of the great things about databases. It's not like an Excel document where, yeah, I'm going to have these be integers, and then you can just type in a word and Excel accepts it. Most of the time. All right, so choose the best data type for each scenario with the minimum storage requirements. Storing a city's population, which ranges from 12 to 24 million, what's 24 million? Well, that's 24 million is like not this one. This is 8 million. 20. Okay, we better use. See, 3 bytes only goes up to 8 million, and we want to go up higher. And so this one, 4 bytes goes up to, 2147 million. So I think it'd be an integer or int. So if we go back to down to here, I would say an integer. Okay, unsigned medium int would go. Unsigned would go up to 16 million, but we want to go up to 24 million. So that's 2. So it's got to be this one. Yes. Storing the annual gain or loss in a city's population, which ranges between 1 million and. Okay, so it's signed 1 million. Well, this one works. So I guess we can use medium int. Signed medium int. So that's what this is about. Storing the price of an item that ranges from a few dollars to a few $100s. Okay, so this doesn't even work. The second number is the number of digits to the right of the decimal point, and the first number is the number of digits total. And so it's got to be this one, because this is 5 digits total and 2 digits to the right of 2 digits to the right of the decimal point. So really, it's 3 digits, decimal digits, 3 decimal digits, and then so from 0 to 999, from 0 to 999.99. So it's this one. I wonder why float wouldn't work. Approximate numbers. Yeah, that's right. Yeah, the trouble with floating is that it just lets everything be in base 2. And when you're converting from base 2 to base 10 and back to base 2 again, you can lose, accuracy, or you might lose some pennies or something. All right, storing the date and time an item is purchased. Well, that would be this one, date, time. Storing students assigned letter grade like an A or D. Well, that could be this one. It can be either this one or this one. Now, I wonder why we would not have it be varchar. I think maybe maybe it's this one. Okay, the grade is a single character, and n equals 1 uses 1 byte to store each grade. Okay, the trouble with varchar is it stores not only what's stored, but also I think it stores like the number of characters, the total number of characters or something. So varchar would be less efficient than char. Is ideal when the length changes, but the length of the letter grade is always 1. So varchar also adds an extra byte, which requires to track each string's length. I think it's a starting point, and then like the length, and then that's that many bytes. So anyway, student's email address, probably this one because it's variable length. This isn't enough, and it's never going to be 100 characters. So this storing yes or no. Status. Okay, so that can be like 0 or 1, assuming it's not nothing. But a tiny int is just 1 byte. Tiny int is 1 byte. Yeah, that's. What else would it be? Starting yes or no. Status. Well, this is only 1 byte, so I'd say it's that one. All right, so we have create and drop. Create and table and drop table statement. So the create table statement is just this, and then it's a bunch of and then it lists the names, column names, and their types, and then it ends with a like that. So it's we're talking about this and this. Okay, so go to, make sure you click through that. Participation activity. So here we're refer to the animation above. Employee table created with 4 columns. 1, 2, 3, 4. That's true. The ID column only holds non-negative integers. That's true. Small int unsigned means non-negative, so that's true. Okay, so click through this to make sure you understand it. Participation activity. So here, write the SQL statement to create this table. So we're supposed to write the create table statement here, and then we're going to insert a bunch of stuff in there, and then we're going to select from it and display it out. So the create statement, the create table statement. Well, I guess I can just write this. All right. Create table product. And I'm going to create ID is tiny int. No, not a tiny int. Let's see. Oh, unsigned integer. Here, let me just go up here. Can I copy this? No, I can't. Can I copy? I want to copy something. I want to copy this. And then I'm going to go like this. And I'm going to go like this and set this aside. And go over here. And go down to here. And I'm going to say create table product. Oh, I got to have a parentheses. Then I want to say ID is small int unsigned, comma, name is varchar 60, and product type is it's a varchar. Is it just 3 characters? Oh, it says right up here. Maximum length 40. I better follow what this says. 40. Maximum length 3 characters. Oh, fixed length string. Huh? Well, fixed length. Why does it say max? It should say fixed length of 3 characters. So anyway, so char is what they want. 3. And then origin date is year, a month, and a day. So that'd be date. And then weight is an unsigned decimal integer. Decimal number. I don't know. 7,2. And then I got to close this thing. I think I just got to close it. What happened? Where is it? Oh, all right. I have an error. Insert into product. Okay. Name. I have an ID. I have a name. I have a product type and an origin date. I have a weight. Insert into. Oh, I need to put a semi. Oh, I need to put a semicolon. That's this. I don't know. Is it right? Okay. Anyway, It's 155. All right, so we can alter a table after we've created it. We can add a column. We can change a column to have it be something different data type or name or whatever. We can delete a column. And this describes that. This adds a salary column. This changes the salary column and gives it a new name and makes it an integer instead. And this gets rid of a column. Add a column called description to the department table. So description. Alter table department. Add description. Yes. Okay, there we go. So make sure you know all these. Creating and dropping tables. This is a challenge activity. I'll do one. So we want to start. And I will go to complete the following statement to create the table named country. So I'm creating a country, create country. And we want ISO stores the country's 3-letter code, SHAR3. And this stores the date. Let's see if this is right. Uh-oh. Oh, I forgot this. Oh, sorry, I didn't finish. Gotta finish. Delete. Delete the table. Why did I delete country? There. Oh, drop. Yeah. Drop, not delete. All right, let's try it again. Create country. SHAR 3. Varchar 56. Delete, no, haha, drop. Country. All right. Is that right? Let's see. Drop. Oh, that drops a column. Deletes a column. How do you drop a table? Drop table. It's just plain old drop table. All right. Drop table. Oh, you got to say the word table, I bet. Oh boy. Okay. Drop table. There we go. Now what did I do wrong? What did I do wrong? Oh, I forgot to put the word table there. Boy, I'm not doing very well, am I? Create table country. SHAR 3. Oh, I don't know. Population is int up to yeah, int. Drop table country. Now watch this not be right. Oh, amazing. Uh-oh, I didn't get that right. Oh, but it gave it to me anyway. Oh, it didn't. Oh, but anyway, it gave me, I didn't say unsigned. It gave me the points, even though I didn't get it right. Huh. I guess it just lost patience with me. All right, well, anyway, so you can go on and do the next one. All right, let's do the next lab. Oh no, this is actually a lab. The one we just did is not a lab. Okay, so now this is points. We're getting points now. It's 201. Okay, so I will make a note on the video. Well, no, you should be able to see because right here it says 3.4 lab. Okay, so that's what I'm working on right now. 3.4 lab. Okay. Create a student table with constraints. Okay, so basically we just have to write a create statement for this. So let's write a create statement for this. Boy, after that last challenge, create table student, left parentheses. And I'm going to want one of these for everyone. What happens if I just do this? Do this, copy, paste. All right, so ID, first name, last name, street. Okay, so this should be an integer. It should be, well, how do I say? I haven't learned about auto increment yet, have I? Shoots. These labs are out of order. Sorry about that. All right, so I guess we got to go ahead. Up and deleting, updating rows, inserting rows in horse table, selecting rows, functions, selecting number of subqueries, complex queries, auto increment. I got to find out about auto increment. Auto increment. Auto increment. See what this says. Auto increment column. Let me go back. Auto increment. Auto increment column. Okay, it's just auto. It's just that. Okay, great. Let me go back. So we were doing lab 3.4, and so I did a create table student, and I'm gonna throw. Well, I'll just type it in. ID is an integer. It can be a 2 byte. 2 byte. What's that? Small int. What is it? What is I'm gonna have to copy. It's lab 3.4. Let me copy this. I don't need that. Where's the? Here we go. I want to copy. Oh, here, creating reference tables, right? I'm interested in this table here. So I'm going to first make it a little smaller, and I'm going to copy this to help me remember. And I do this for you more. So I'm just going to set this aside and refer to this later. And let me go back to my lab now, finally. And I'm making a create table, table student, left parentheses, and I'm going to have an ID, and it will be a small int, unsigned, small int. You know, there's a lot easier way to do this, and I'll show it to you. I'm going to go to my web my Richard H at this, and I'm going to go to cPanel, and I'm going to go to log in, and I'm going to go over to my phpMyAdmin. No, I'm not going to do that yet because you might not have done this yet. I'm going to go to MySQL databases, and I'm going to create a new database called test2, just because I already have a test. That's fine. So now I've got a database called test2. It's in there. And so now when I go back to phpMyAdmin, I see there's a test2. So now I've got a blank database, and in my blank database, I'm going to create this table. Okay, and I'm going to see what it says when I create it. So let me go here. I'm going to take this out, separate it out, set it over there, go back to here, and I'm going to create a table called, close this. I'm going to create a new table called student, and it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. Now, this isn't going to come out exactly right, but it'll come out close enough so I'll be able to take what this thing says and figure out what the answer should be. So, where am I? 100. Okay. I have a column called ID, and this can be a small int because it only needs to be a 2-byte integer, signed, unsigned. So how do I make it unsigned? Unsigned, and it's auto increment. That's just AI, auto increment. And it's going to be the primary key, I guess. It's got to be primary key if it's auto increment. And so that takes care of that. Then there's going to be a first name, and that's going to be that is a 20 characters. It's going to be a varchar 20 characters, not null. So this is unchecked. Next one is going to be last name. And this is also going to be a varchar 30 characters, not null. And then there's a street. And this is a varchar of 50 characters. And then there's a city, which is a varchar of 20 characters. And there is a state, which they would like it to be a character of 2 and not null. Default of Texas. All right. And then the next one is zip code. ZIP, which is an integer up to 16 million. I guess that can be maybe medium integer, unsigned. Medium integer unsigned is 0 to 16 million. Is that what 0 to 16 million? Okay. And then we have phone, and that would be a fixed length string of 10 characters, character 10. Not null. And email, which is a varchar of 30. All right, I want to see what happens, what this gives me now. So I'm going to hit go or save, and it produces this. And well, what did it do? You can go up here, you can go to export, and you can say SQL, you can do custom, and it doesn't have any records in it. So what happens if you go see create table, auto increment value? I'm gonna just click on this and see what it looks like. Oh no, I don't want to do that. I want to view output as text. Click go, and this is what it gives me. Now, it sort of put this outside. It put this, okay, so it did this. It made it this. So I'm gonna do ID small. Okay, so I'm gonna add this unsigned not null auto increment, because not unsigned not null auto increment, it likes to have it all in one line. And primary key. So I'm going to do this, copy this, and put a comma, comma, enter, paste. I think this is how you do it, and I don't need any of this. I guess I should have a semicolon there. All right, I'm going to try to. Oh, and I don't really need these back ticks. I'm going to make a new one. Go back. I'm going to take out the back ticks. All right, custom SQL, view as text, enclose in an export transaction. What happens if I take this away? Export as views as tables, disable foreign key checks. I only need the structure. I don't need add create table statement. I don't need this. I don't need this. I don't want to enclose in back quotes. Let's see what this gives me. All right, so really what I want is, I guess I need the primary key in there. Copy this, comma, enter, space, space, paste. And I think I need an auto here, unsigned, not null auto increment. Unsigned, not null auto increment. Okay, this is, and I don't need this. All right, I'm going to take this and I'm going to copy it. And I'm going to go over here. And here I am. And I'm going to paste it in here and see what happens. Paste. Okay, so there it is. See what happens. Run the program. All right, let me just submit it and see what happens. Submit for grading. Eight out of 10. What did I not get? Oh, really? It expected yes for no. What is uni? Must be unique. Ah. And it doesn't say not null. Okay, sorry. Let's go back to this now. No, this one. And let's go. Okay, so all right, let's go back to structure. And we want to make phone, email, we want to make it unique. So I click here and I go to unique. So now it's unique. And then I also want to make it so it can be null. So let me change this and say that it can be null. Save it. Okay, now I can go to export and custom, and I want to view as text. And I'm gonna whatever. I want the create table statement. I don't need that. I don't need that. And I don't want the backticks. Go. And here I am. And I want not auto inc. I want auto increment up here. And I also want unique. Is this how I do it? I wonder if this will work. I wonder if that'll work. So this is what I think it is. Copy. And let me go back to here. And I'm going to paste this in here now. And let's see if this works. Submit. Oh. Wait. Submit for grading. Yeah, sorry. All right. It did not like this. So I'm going to try it this way. Unique. If that works. And I'm going to take this out. Doesn't like something. All right. I'm gonna. Oh, it doesn't. Oh, I wonder if that was the problem before. Okay. Well, anyway, I gotta take that out. I should have looked at this. Well, let's see what this does. All right, the uni is there. Okay, so that looks good. All right, it's 2:28, and so we covered the remainder of chapter. No, I'm sorry. We covered chapter 3 up to lab 3.4, and we did lab 3.4. It was a little more difficult. I think I'm gonna have to move this lab to later on in this chapter because there were some keywords we haven't learned yet. But anyway, I hope this helps, and I will see you next time. Thanks for watching.